Hi everybody, welcome to the self-check section 8.1 video. Let's go ahead and take a look at number one. So number one says, suppose we have data from a sample. The sample mean is 15. That means X bar equals 15. We also have that the error bound is 3.2. That means our error is 3.2. And so what we are being asked here is what is the confidence interval for the population mean? So let's go ahead and figure that out. So confidence interval, for the confidence interval, we have our mean and error already. So we're just going to write it in form, particularly form number two, where we have an inequality. So our sample mean minus the error less than the population mean less than the sample mean plus the error. So let's go ahead and plug in our values now. So 15 minus 3.2 less than the mean less than 15 plus 3.2. And so this comes out to 11.8 less than the mean less than 18.2. And that is our confidence interval. Okay, we weren't given uh standard deviation or anything of that sort. So we were able to find a confidence interval with just the error and sample mean. So let's go ahead and look at number two now. So number two says, suppose average pizza delivery times are normally distributed with an unknown population mean and a population standard deviation of 6 minutes. Okay, so that means sigma equals 6. That's our population standard deviation. And then we have a random sample of 28 pizza delivery restaurants. So that means our sample size is 28. And that we have a sample mean delivery time of 36 minutes. So X bar equals 36. And we want to find a 90% confidence interval. So our confidence level is 90%. And we turn that into a decimal. And we're trying to find a population mean delivery time. And lastly, right, an interpretation. So we have our standard deviation sample, our sample mean, and a confidence level. So what we need to do here is construct a confidence interval. So confidence interval, and we're going to use Z interval. And since we aren't given a list of data and we're just given a summary of the data, we're just going to use stats. But let's jump to our calculator and input this information in to get our confidence interval. So we're going to go to stats, go to tests, and then Z interval. And we're using stats. And we just go ahead and input all our data we have. So our standard deviation is 6. Our sample mean is 36. Sample size is 36. Sample size is 28. Confidence level is 0.90. And we're using stats, and we just go ahead, hit calculate, and that's our confidence interval, 34.13 and 37.87. So let's take this confidence interval and write up an answer. So stats, where we got to write our calculator work. So 6, 36, 28, and 0.9. And then when we did that calculation, what we got was 34.14, less than the mean, less than 37.87. So that is our confidence interval. Okay, so that takes care of the confidence interval. Now we need to write an interpretation. So with these confidence intervals, it's pretty much the same interpretation. We just have to interchange some language in the context of the problem. So what we would say here is we estimate with 90% confidence that the true population mean pizza delivery time is between 34.14 and 37.87 minutes. Okay, so that's our confidence interval, and that is our interpretation. All right, let's go ahead and check out number 3 now. So number 3 is saying how many adults. So right away when I see that how many, that tells me I need to find a sample size. That's always your indicator, how many. But let's read through the rest of the question. So how many adults must be randomly selected to estimate the mean FICO score, mean credit rating, score of working adults in the US? So we want a 95% confidence, and we are within 3 points of the population mean, and the population standard deviation is 68. So we have a couple key components here. So confidence level is 95%. Sample mean is within 3 points. So that means error is 3, and the population standard deviation is 68. Okay, so recall that the sample size formula is our critical value for our confidence level times the population standard deviation divided by our error, and that is all squared. So we have our population standard deviation, we have our error, but we're missing our critical value. But we have also found this critical value for a 95% confidence level. So I'll say we have previously, I'll say shown that for a 95% confidence level, we have a critical value to be 1.96. So we can just use this 1.96 and find our sample size. So let's finish this out. 1.96 times 68 over 3 squared. So it's always best to just take it one step at a time. And so let's multiply the top component first. So 1.96 times 68. That turns into 133.28 over 3 squared. And then once again, it's better just do this in parts. So I'm going to divide 133.28 by 3. And what I'll have here is approximately 44.4266666667. Just a really long number. How many you need to convince yourself And then I'm going to square this last step, and this ends up being 1973.7. But remember, we always round up, and this ends up being 1974. Okay, so that's our sample size. So here we're not asked to do an interpretation. So what we'd essentially have is 1974 score or FICO score. Okay, so that is questions 1 through 3. And that's it for this self-check video. Thank you for watching. I will see you next time. Bye.